Okay, maybe we can just start from right now. So, thanks for only one people coming today. So, if you have any questions, you can interrupt me at any time. So, uh, could you tell me, could you hear my voice? Okay, so in this tutorial, in this online tutorial, we are aiming to introduce the reinforcement learning. So today we will go through some fundamental concepts of it, and I will show practice for how to use the balance equation to update the Q table, which we have learned in the lecture and tutorial. And also, I will introduce a Python practice on deep Q network to practice on like AI gym environment. So the first thing is what's reinforcement learning? So this is a very special machine learning algorithm, and it consists of an agent and it interact with the environment, and the environment will receive some feedback to the agent with form of rewards. So imagine we are playing a Mario game. So Mario is the agent and he's running or jumping, and the environment will give them the scores. So our goal in this technique is to then what's the optimal behavior for the agent to get the best rewards from this environment. So let's go through some details. So the environment the environment defines some state. So we call the state as S. So the state could be the position or the condition of the environment. And we are here agent is the decision maker in this environment. So based on the state in this environment, the agent will take the action to interact with the environment. And the policy is defining how the agent will take the action based on the current state. So to define whether the action is good or not, we will use the reward. So there are two kinds of rewards. So the first one is intermediate reward. So that is just the quick feedback from the environment. So if I take an action to the environment once, it will give me a quickly feedback. But if I take a series of action, I can get a series of reward and sum them up. This is called accumulated reward. So if I follow a policy to do a series of action, I will get a series of reward. So I will record it as an accumulated reward so that we can compare the accumulated reward between different policies to see which policy is best for me to take actions. So here is the Q function. Q function is our recorder for this accumulated reward. So each state action pair follow a certain start from a certain policy and start from a specific action state pair, we can get a cumulative reward. So the Q function is recording all the possible situation and their values. So here is practice for using this queue function to update our queue table. So we are using this balance equation to guide us to update this table. So first, let me introduce the notations in this equation. So S and A are our current state and action, and X prime is next state after I taking the action currently, and Q table. So Q value for state action pair estimates the estimate the rewards from our environment. So so this one it also means the current estimate of the Q value. So if I want to update this Q value, so we will start from the original one, and this is the updated one. So in this part, R is the immediate reward received after I taking the action A here. And here gamma is the discounting factor to define how much I will count it the rewards from our environment. This term could stop us from learning too much rewards from the environment so that we can control our learning steps. So this one is to represent the maximum estimated future reward from our next state and next action. So specifically, this is our current state, and by doing this action based on this state, we will go to the next state, and the next state, in next state, we will choose action, and the rules for us to choose the next action is to take them back, is to choose the one with the maximum Q value. So this terms thing means. So the rewards plus our new Q value is showing that the new information obtained from the environment. Also, we can learn it. This is a kind of next steps Q value. And by minus the old Q value, we can know the difference between the update value for our current Q value. So we sum so that we can get an updated value and to replace the original one. So next we will use a example with some numbers so that we can understand it better. So the first step for a Q value, for example, here in this environment, we only have two states, S1 and S2, and we can only take two actions. So we record it as A1 and A2. Our first step is to initialize a Q table. So at the initialized one, the Q value here are all 0. So here we can set something for our environment. So we choose to start from this state and this action, and the policy here is to if I take this action, we will go to the next state for S2, and I will get the reward of 10. And for another parameter setting, the lending rate is set as 0.5 and the discount factor is set for 0.9. So we will use this equation to do an update for this zero value. So currently our S is S1, A is A1, and S prime, which is next state is S2. So Q value from here now is 0, and the maximum Q value for S2 here, we will go to this row and we will choose the max Q value from this table to choose the action. But here for the initialized table, the maximum one is 0. So we will choose it from here. So this is 0. And also we got so here we take 0 to the original one, and the learning rate is set it, and we got a feedback by doing this of 10, and plus gamma, and the 0 for next Q value, and minus the original one. So we get a updated value for 5, and we can update it to this position, to this original position. So this is the first step. And we continue to doing this kind of operation to update the Q tab, to do the Q table. So currently, after doing this, we now in the state 2. So our current state for now is here. And here we choose to take the action with A2. And follow the policy, we will go to the new state of S1 and get a reward of 4. So again, use this value equation. We can use this value, put this value into this equation, and we will get the updated value for this grid. So we can take it into our table. So let's two steps to do the Q table update, and by doing all of trying all the possibility for all the Q table. So until the Q table, until the Q value for this grid is not changing too much, we will see maybe this is the best reward, but this is best Q table for us to choose the final policy, so that we can get a updated to get a final Q table. So this is a case where we use the Q table, but however, when we have a continuous situation, like we are training a robot to learn some action, these state and actions will be continuous number, and that will be very, very too much value to save in a table, so that we can design a neural network to use as a function of Q table to help us to update. So here we will show a code practice for training a deep Q network. So let me change my screen. So this is our online tutorial for code. So our goal in this code here is to train deep learning. And we will use the environment from OpenAI. So let's start from some fundamental installation. So the first one is we will use the PyTorch framework. So we import LAN, and we will use the neural network to use the function as QTable. So we will import the neural network modules from the PyTorch. And also we will do some parameter optimization. And so we will import this function from PyTorch framework. And the next step is to import our environment. So Gym is open source toolkit provided by OpenAI. And this is the environment, a good environment for us to developing and training our reinforcement learning algorithms. So it can train the classical control or robotics or video games. And in this time, we will try a small robotics I will introduce later. So the next step is to install some other modules. So this one is a part of our DeepQ network, and it and used as experience play buffer. So I will introduce later. And this one is for action selection. And this one is to do some plot as a fundamental Python function. And this is to do some numerical calculating. And this is for also for our experience display. So next steps is to initialize our environment. So the environment we choose here is cart pole. So what we do is to apply some. So this is a car, and this is a pole. So we are doing some actions, like we are applying some forces to this card, and our goal is to keep the pole balanced and without falling over. So this is our goal, and there are some. So the actions we can do is to push a car to left and to push a car to right. And the state, which can describe this environment, is we have 4 states. The first one is the cart's position here, and the second state is the cart's velocity. So it can tell us the direction this car to move, like towards left or towards right. And the third state here is the pole angle. So the pole is not always upright here. It may have some angle because it's going to falling down. So the angle is a parameter to describe it. And also the angular velocity for pole is to describing whether the pole is falling down from left or right. So this is 4 states we have, and we have 2 actions. So and the rewards here is corresponding to our goal, because our goal is to keep the pole upright. So if we keep the pole upright, and going some and moving some steps. So for each step, we will get a reward of positive one. So that's the rules for this environment. So here, let's come back to the code. So here, we initialize this carpool in James into our environment, and we are the human to do this action. So and this code is to check whether we initialize it well. So here we set all the fundamental things in our environment. So the first step for us is to define a neural network. So as I said just now, it can approximate the Q value function. So the structure of this neural network is so it will has three layers. So the so here is the first fully connected layer. So we will input our input our state into the first layer, and this is a fully connected layer, and this is our input as state, and they will and then it will go through a activation function, and the output is a hidden state, and the hidden state will go into the second fully connected layer, and also the input is the hidden state. So also we choose the this nonlinear function, and the third layer is the output layer. So our hidden state, which is transformed from our state, the output is the action side action. So the output is actually the Q values for each action. So it means if I start from this state, I input, this neural network will give us all the possible Q values for every actions. So this is the input and output of our neural network, and this one is to define how the variable or information will go through in this neural network. So we choose a forward strategy. That is a very straight forward pathway. That is, our X will first go into the first layer, and then go to the second layer, and then we will go to the three layer and directly as the output. So that is our deep neural network. So here we define the Q table for how we will train this in this process. And next we will define how the agent behave. So for the agent, all the parameter we need is also the state and action here. As we introduced in that website. So the first different thing here is we will have an experience replay memory. So for a continuous intuitively, for a continuous training, we will train the state and action by following a time order, but this is very like if we follow a time in order to do this training, it will be too redundancy for us to learn all of it. So we will set the experience replay buffer to save some past experience as like as our state, action, rewards, and next state, and so that we can grab some past experience from it to train our model instead of doing it step by step. So I will introduce it more detailedly in the code below, but this code is to define the length. So we define 10,000 of our memory here. So the next steps is to set our learning learning hyperparameters. So gamma and epsilon is I have introduced in the Ballon equation. So this is for account. This is the discount factor for our future rewards, and this is for a balance for exploration and exploitation. So we will set it as 1 at the first, and then we also set the decay rate for it. So for every learning steps, the first one we will do a fully exploration thing, and then for the next steps, the epsilon will decrease, so that we can use more old experience instead of trying new things, so that it will make us learning more efficiency. So that is setting for epsilon, and the learning rate also in the equation is for it's also controlling our learning space. So the batch size is to do, like, if I set 64 here, so we will train 64 samples at the same time, so it will save times for us. So this is some parameters. And also we will use the Q network here because we want the Q table for our, if our agent take an action. So we will initialize the Q network we defined at here to put it here. So for this Q network, I'm updating it very quick, step by step. So for the parameter, we also need an optimizer. So here we introduce optimizer as add-on here to update our parameter. So this is also from PyTorch framework. It's very it's a fundamental thing. And we also have a loss function to calculate our loss in this process. So here we choose mean squared error here. So the next part is to define our memorize part. So the memorize here, I said, is to store some past experience. So the past experience is defined as a series of state, action, and the rewards, and where you will go to for next state. So this is all the information for us for one experience. And the add is to define our action. So our action show here is to do so it's for us to, so this is for how we can choose the action. So sometimes we choose the exploration that is randomly choose the action from the table we have, and the exploitation is to pick the maximum Q value from our corresponding to the action from our experience replay. So so this means exploration. So let us select a random action. And after we do this action, we will save our state and all the information. So this is for convert it to a tensor so that we can save it very convenient. And also we get the Q value from it. So this is for exploration to save all the information from a random action. And this is for exploitation, that is select the highest Q value. So this is our action function here. And the replay buffer is our memory here. Also corresponds to the experience replay here. So the memory is so the step to use the memory is first thing first. At the beginning, we don't have any saving for memory, so we will accumulate some memory, and until it is it ups to a bench size, then we have built our experience bank so that we can start from we can start to use this experience replay. So here we also should define the mini bench for our for defining how many samples we need for this bench. So and this code is also defining what's the memory. So we need action, state, reward, and next state. And this is an operation to convert this to tensors, so it can be read by our algorithm. So based on this memory, we can get the Q values from our Q network. So here we can get the updated value from our Q table. So this is for current Q table. And this steps is also for exploitation. So we will compute the maximum Q value for our next days here. And then we will update our Q value. So use the balance equation. So these three steps is actually very like the use case I introduced in our tutorial document. So this is our current state. This is the next steps, and we updated or arranged the one. And also this loss function is calculating the current Q values and the target Q values loss. So our loss is to if the loss is near to 0, that means our chaining is almost down. So in this setting, we will use back propagation to update our network weights. So these three are our optimizer to reset the gradients and compute the gradients, and then we update our weights by a backward propagation algorithm. So this one is to make our epsilon here from a fully exploration state and decay to and doing the decay. So let's for next step, we will not doing too much exploration. So this is the rules to use the decay parameters to into our epsilon. So that is all the settings for our how the agents will do. So the next step is to train our agent. So here to train our agent, so here the first step is to define how many times I will train. So and how many times is called episodes. So here we define we will train 500 times. And also we will input our state size and action size. So here in our cases, we have 4 states and 2 action. And also we will introduce our agent, use our agent function into our training process. And we create a list to install rewards. So this is a loop to doing our training. So for each training step, we will do these things. So this is our this is to get some state and additional info from our environment. So that's it. And currently our total reward is 0. So this is the step by step for us to take actions and get rewards from the environment. So in our 500 times, we will use our add function as we defined in our agent here. So this is our add strategy. So this means here we get the state, and here we will take the actions, and here we will receive our next state and reward from this time. And then we store this information into our as the memory here, and save it into our experience replay. And then we will update our state here because we have already taken actions, and also update our total reward because we also get a reward from last time. So this is an update for our current current situation. So this is for us to visualize what we do during this process, and I will show you later. So and if this episode is done, we will get the output for us to which episode we are and how many scores we have, and what this is also what's the episode here right now, and then down. And this is the plot. And finally, we will plot our rewards for how it will increase. So if I want to run this code, so here is the output for every episode. So every episode has our score and epsilon, and it will change for 500 times. This is the training performance for how our rewards change during this time. So this is the reward plot. So for the plot for visualizing our card poll, I will let the lecturer to share his screen.
Yeah, or share my screen. All right, here is a code for the uh, reinforcement learning. We use a carpal environment as introduced by Ruby. So I have sort all the codes um, into a Python file. And one thing I want to mention is that the gym version from my local environment is different from the one on Colab. So there has slightly different. For example, here we have 5 output where we execute an environment step. Yeah, it's because of version. Yeah, there has this minor difference. Yeah, so I will just run the code. You can see the result. Here we can see a nice visualization of this game. And here to show you the scores obtained. Right, so we can see the score is increasing. So it's like after nearly 50 episodes, we can see it can somehow balance the couple, and the score is still increasing. So I think the maximum score would be 500, because for each step it will get a one reward. So score here just means the total reward without any discounted factor. This is what is printed here. Let's wait for a few more episodes.
I can see it's becoming more stable.
Yes, become more stable. I just try to see if the score can reach to
Yeah.
500. Yeah. This one will achieve 500. No. 462.
It's good.
Yeah. So this is a problem. So sometimes it can um forget. Yeah, I think because here I can see we still have a lot of episode to train, so I will not train until you finish. We will just stop here.
Yeah.
It's really hard for it to get 500. Like there has another reason. It's because we have added the random explanation, so it will not necessarily follow the always follow the maximum Q value. The action raised the maximum Q value, so it can sometimes give us some random explanation. So advantage is that we can avoid to stuck into the local minima, but there has a disadvantage is so, because of the random explanation, sometimes it will just take the action randomly, and if our Q value is already good enough, maybe it will select the suboptimal action to do. Yeah, we'll just stop sharing.
Yes. So if so the final result I can show here. So final result here is this is the reward plot for how the reward change. So this is like the final result. Yeah. So that's all for our online tutorial. Uh is it okay to just stop here? Or if you do you have any questions?